Okay, students, let's look at this question. A particle of mass m is equal to 1 kilogram has an initial velocity of 2 meter per second. A force of 2 Newton acts perpendicular on it for a time of 1 second. Find V, that is final velocity, displacement, let me write S displacement at the end of 1 second. We have to find out the final velocity and final displacement. For that, let's have a diagrammatic representation of it. In order to represent it diagrammatically, let me draw the XY axis. Let this be our X axis and this be our Y axis. And now we are having the substance which is moving with an initial velocity of u is equal to 2 meter per second. That means, let me take the substance is moving in this direction. It's moving in this direction with a velocity of u is equal to 2 meter per second. Therefore, we are assuming that the initial velocity is in x direction. Therefore, I could write u is equal to 2 I cap. Why did I write 2 I cap? Since unit vector in x direction is I cap, therefore I could write u is equal to 2 I cap. Okay. Then we are given that a force of 2 Newton acts perpendicular on it. That means the force acting over the substance, it is perpendicular. Therefore, we can take it in y direction. And as we know F is equal to MA, we could say MA is equal to what? 2 Newton. Then A is equal to means it is 2 by M, that is 2 by what is M? It is 1. Therefore, acceleration is 2 meter per second square. And since the force is in y direction, we could say the acceleration will be also in y direction. Since the acceleration is in y direction, I could write acceleration as 2j cap. It's because it is in y direction. Therefore, now we have initial velocity in its correct vector and acceleration in its correct vector. We have to find out final velocity. Since we know time is what? In a time of 1 second. Therefore, we know time, acceleration, initial velocity. In order to find out final velocity, we'll use our equations of motion, that is v is equal to u plus at. And if we are substituting it, we will get final velocity v is equal to initial velocity, it is 2 I cap plus a, acceleration is 2j cap into t is 1. Therefore, we will get v is equal to 2 I cap plus 2j cap. This is our final velocity in its vector form. Then if we want to find out the magnitude of final velocity, it can be obtained by root of 2 square plus 2 square, that is root of 4 plus 4, that is root 8. We could write it as 2 root 2 also. Since 8 is 4 into 2, we will get 2 root 2 meter per second. This is the final velocity. And in order to find out the displacement, we could find out the displacement by using the equation S is equal to ut plus half at square. And let me substitute the values. S is equal to u. What's u? U is 2 I cap into t is 1 plus half. What's a? A is 2j cap into t square means it is 1 square. Therefore, we will get S is equal to 2 I cap plus 2 into 1 by 2. It will get 1. Therefore, ultimately it is j cap. Therefore, the displacement in its vector form, it is 2i cap plus j cap. And if you want to find out the magnitude of displacement, it will be root of 2 square plus 1 square, that is root of 4 plus 1, that is root 5. Okay, that much neat. This is the answer for this particular question. Now we will discuss one more question in that similar format. Now look at this question. A substance is moving with an initial velocity of 2 meters per second and its acceleration is 2 meters per second square. It acts for 2 seconds at an angle 60 degree with respect to initial velocity. Acceleration is acting at an angle of 60 degree with respect to initial velocity and it is acting for 2 seconds. Find the final velocity displacement at t is equal to 2 seconds. Let me write displacement as xs. Okay. Therefore, let's solve this question by remembering about the previous question. In this case also, we are drawing the xy axis. Let me draw this as x axis and this as y axis. Now, we are having a substance which is moving with an initial velocity of 2 meters per second. Let me take this velocity u as 2 meters per second in this direction, that is in an x direction. Therefore, I could clearly write u is equal to 2i cap since it is in x direction. You know. Then acceleration, now it's not perpendicular. In this case, the acceleration is at an angle 60 degree with respect to u. Therefore, I will have to draw, look here carefully, I will have to draw the acceleration in this direction. This is our acceleration. It's making an angle of 60 degree with respect to initial velocity. Then I could resolve this acceleration into two components. One component like this, let me call it as ax, and one component like this, that is ay. Therefore, I could write acceleration in its vector form as ax I cap plus ay j cap. Can I? Acceleration can be written in its vector form as ax I cap plus ay j cap. Okay. Then, as we know, a is what? 2. Therefore, ax will be the cos component of a, that is a cos theta. Ax will be 2 cos 60. Is that clear? Ax, it should be 2 cos 60. And ay, it will be 2 sin 60. What is 2 cos 60? Cos 60 is 1 by 2. Therefore, 2 into 1 by 2, that is 1. Then, what is sin 60? Sin 60 is root 3 by 2. Therefore, 2 into root 3 by 2. That means it is root 3. Therefore, ay, it can be rewritten as root 3. Ax can be written as 1. Therefore, I could write a is equal to ax I cap means 1 I cap. 1 I cap can be written as I cap. Plus ay j cap. Ay j cap is root 3 j cap. Okay. Now we are having acceleration and initial velocity in its vector form. We know time. The time is for 2 seconds. Therefore, let me write t is 2 seconds. Then we'll use our same concept that we have used in our previous derivation. That is, in this case, we found out v is equal to u plus at. In this case also, we are going to find out v, and it is determined as v is equal to u plus at. Then v is equal to, what's u? U is 2i cap plus a, it is I cap plus root 3 j cap into t, it is 2. Okay, let me Yeah, differentiate these two. Okay, now we are having an equation like this. Let me simplify it. 2i cap plus 2i cap, that will be 4i cap, plus root 3 into 2, 2 root 3 j cap. Now we are having an equation like this. This is our velocity in its vector form. And if you want to find out the magnitude of velocity means it is root of 4 square plus 2 root 3 the whole square. That is 4 square is 16, 2 root 3 the whole square is 2 square is 4, root 3 square is 3, 4 3s are 12. Therefore root of 16 plus what, 12, that is root of 28. It can be written as root of 7 into 4, that is root of 4 is 2, therefore 2 root 7. That much meter per second. Therefore, now we have determined the final velocity's magnitude. Likewise, we could find out the displacement also. For finding out displacement, we could use S is equal to ut plus half at square. Then S is equal to, what is u? U is 2i cap. Therefore, 2i cap into t, it is 2 plus half a. Acceleration is what? I cap plus root 3 j cap. Therefore, I cap plus root 3 j cap into t square. T square is 2 square, that is 4. Then we will get 2 into 2i cap, it is 4i cap, plus 2 and 4 will get cancelled. Then it will be 2i cap plus 2 root 3 j cap. That means 6i cap plus 2 root 3 j cap. This is your answer of displacement in its vector form. And if you want to find out the magnitude of displacement, it should be root of 6 square plus 2 root 3 whole square is 4 into 3. Okay, therefore 6 square is 36 plus 12, that is root of, let me write it over here, root of 48, and root of 48, it is root of 16 into 3, I think. Then it is 4 root 3, that much meter. Okay, this is your displacement. Hope you have understood this.